little bit about like sets. Well, sample space looks like this. In sets, well, there's set A, and maybe there was like a subset inside A that was like B. Okay? But now what we're going to do is more of a Venn diagram look. So what if we have a sample space, and this is set A and set B, but they have some elements that are in common. Right? And maybe they have some shared and some not. So it's going to be more of a Venn diagram type, which I know you know that. You've seen that in science somewhere, I'm sure. All right, so here's what we're going to do. We have two sets A and B. And the union of those is going to be anything that's in both of those. So it could be in A, it could be in B, or it could be where they cross. Okay, anything in between those two sets. We call this the union of the sets. The symbol we use is this. I remember it because it's a U. It basically looks like a U, so it's a union. But we also use the word or. We also use the word or. So again, this is just right. So some note that this is just everything in those two circles, like everything included. Contrast that with and. So this is intersection. The intersection is where they overlap. So in the Venn diagram, it's just, I'll put it over. The Venn diagram part is just the shared spot. I think of intersection as just, I just call it the overlap. Okay, now there's two ways that they could give you this. They could write the word and, A and B, or they give you the symbol for and, which to me looks like an N. And that's why I think of intersection. Intersection has the N in it, and the word and has the word, or has the letter N in it. Just trying to give you some clues up to remember which one is which. Now, what we're going to do, there's one key probability formula about adding probabilities. It's on the formula sheet, and we're going to build to that. Any initial thoughts about and or sets? And or. All right, well, let's go down here. Let's do example one. I'm going to mention a few of this right here as we go along. Here, I got set A. It's got some numbers in there. I got set B. More numbers. Find their union and intersection. So this is A or B. Right, that's the union symbol. I'm going to write it as a set. So I'm going to put the little bracket thing there. And I'm listing for or, it's everything in those. Now you don't list the number twice. Okay? Don't list it twice if it's in there. I'm going to start with set A and go with 1. I'm going to list it numerically. You could really just write all of those down first if you wanted. I'm going to go numerically. So I'm going to jump over to set B. It has 3. 7 is in both. I'm just writing that once. Just a number that's in there. It's in A or B. Yeah, it is. 7. 9, 11, and the rest here. 12, 13, 17, 23, and then 45 and 56 to finish up. That was A or B. All right, let's contrast that with and. Right? This is the intersection. So A and B, again, you just write the little brackets. And this is everything that's in the overlap, everything they share. So let me clear this off up here a little bit again. Just looking for, in this case, numbers. It could be other things. Numbers that they share. So 7, what else? 12, 17, and then 23 and 45. So we listed elements in A or B and the elements in A and B. And now we're going to build to a formula. So here's the formula in example 2 that you might think would be true. You might say, all right, the number of terms in A or B, right, all of them there, all of them there. That's got to be equal to the number of terms in A plus the number of terms in B. By the way, N is number, right? Number of A. Number of terms in A, elements. So you might think A or B, that's everything, is equal to the number of terms in A plus the number of terms in B. That's actually not true though. So let me show you why. Let's count it for this one. So I'm actually going to list the numbers here, and we'll see that it doesn't work. So I'm going to count the number of terms in A or B. That was this one. So me do A and B and see if they sum to 11. So A up here, it's like 8, plus, and then B, also 8. And clearly that's going to be 16 and not equal to 11. So that formula did not work, but there's only one slight adjustment we can make. So does anybody see, what was, so I'm on B here. What's the problem with this formula? Anybody see what the problem is or how we could adjust it to make it better? No, good try. That's okay. Why didn't this work? So we did all the terms, all of this, right? A or B is all that. That should be equal to this plus this. That's what we had. What's the problem when we do that? I think we should know. Yeah, somebody should.
Subtract the similar terms after adding the two first.
So the problem is the middle, right? When I do all the terms in here and all the terms in here, I count the intersection twice. See that when on the grid? We count that middle part twice. The overlap is the issue. Thank you. So I just put, why is it not true? Well, we showed it there. It's the overlap. You could say it's counted twice. And so we can adjust it just as he said there. We can just subtract off one of the overlap. So a slight adjustment to this formula. The number of terms in A or B is equal, I'm writing this exactly, is equal to the number of terms in A plus the number of terms in B, but if I leave it like that, I counted the middle twice. So I'm going to subtract it off, minus the number of terms in A and B. So now by subtracting it one time, I've subtracted one that we didn't need, and now I'm back to just one of all the middle terms. This is the probability, this is called the addition rule for probability. It works for if you're counting numbers, or as you can see here, it works for probabilities. It is the exact same formula, but this is for numbers and this is for a probability, but it's the same. Okay, now again, this is on the formula sheet, so that's great. You can go and memorize this one. It even says the addition rule. So, and they write it with, they don't use the symbols on here. It's nice, they use or and. So there's the formula if it's probability. And I even have it here numbers again, if you wanted it. Any initial thoughts before we try some examples on this formula? Okay. So right here we built to it. I was just showing you an example where we led to this formula. Now we're going to see a couple different examples. All right, now basically we've seen two types so far: table questions or kind of word problem, where they just give you all the information in words. I gave you a little summary chart of what to do. If they give you an or question, you must use the formula if it's a word problem or a table problem. You gotta use this formula. If it is an and, so this is, what's the probability of A and B? If it's a word problem, you must use the formula again. But this is the only one where there's a nice, easy way if it's a table. Alright, so if it's a table, so we'll see that on the next page. There's an easy way to do that type. So there's a summary if you're sure, okay, it's A and B. Well, what do I do? Is it a table? Is it a word? Follow this chart here. All right, let's try one. So at the bottom, they've given us two events and their probability of A and B, 0.64 and 0.32. And they've given us probability of A and B as well, 0.18. The probability of A or B, I'm just using this formula. You can rewrite it all again. I'm just going to go directly from here. So A or B, A is 0.64 plus the probability of B, 0.32, minus A and B, which is 0.18. Okay, we sum those and then subtract. Okay, just for time to say we get 0.78. 0.78%. Let's go to page 2 and try a few. I got some table 1 on the next page. Okay, any thoughts on that one? Alright, so I got some table 1s here. So flip the page. And sometimes these are called tables, table problems, a chart. Sometimes they're called two-way frequency tables. Mention that in case you see that word. So let's try a few. This is a high school. They surveyed 52 seniors. What are you going to do when you graduate? They've got going to college, not going to college, broken down by gender. M is going to represent male, so we don't have to keep writing the word male. C is going to, F is female. C is going to represent if you're going to college, and N is not going to college. It's rather than writing down those words all the time, it saves us some time. Okay, now over here on the chart, I did already fill it in on this one for you, but really they won't always give you the total. So if they don't, it's nice, you're pretty much mostly going to need a total. For example, the first thing I would do if you don't have it is just sum this column. You get 30 male and 22 female. And then go into college, I sum the row and get 29, and here I get 23. So you don't have a total, you might need, and their total is 52 in the survey. If you add this row or this column, it's going to be 52. So some of the practice ones I don't always give you the totals, you will need to find them. Okay, here we go. So let's find some numbers and probabilities. First one is number of male. Okay, N is number. Number that are male. This is why I decided to do that sum. It's 30. Right, this is no probability, just the number. I'm going to quickly do the rest of this row here. Female, 13 and 9, that was 22. There. College is the 29, and not going to college is the 23. Okay, now the second row here, this was the only difference I made in here is probability. And this first two rows are actually a review from yesterday. I wanted just to recall. Probability is now the number of male, in this case, over the total, which is 52. And the same for all of them. Female, there are 22 over 52. So all of these are just the number above it divided by 52. Now let's not simplify those. I'm just going to leave it like that for today, just because we're a little short on time. Now we're going to get to some and or questions. So let's do the and one. Probability of male and college. This is the one I said from a chart. This is actually an easy one. You don't have to use the formula. You literally just look for male in college where they intersect, and you got 60. Now this is still, okay, what's the probability of picking a student who's male and going to college? 16, still out of the total, 52. So don't adjust that total. There's something we'll do in the future here where it won't be out of 52. But for this one it is. So let's do it. We got female in college now in the next one. Female, college, 13 out of 52. Okay, so at the table one, let's finish up with an or question. Or, if you forget, you can look back at my little summary chart down here, but there's no way around it for an or statement. They want A or B, you have to use the formula. So don't look at the chart and think that there's some shortcut. You just got to use the formula and plug in the numbers. So they did F and C. I'm going to transfer this formula back here. Instead of A and B, I'm just going to use F and C. If you'd rather you keep it as A and B, you can. But I like doing this. So I'm going to say it's the probability of F. Okay, before it was A and B here. Plus the probability of B, which is now C. Minus the probability of previously A and B, now it's F and C. Okay. let's see. So then I just have to compute these three. We actually already have all three. If you didn't, you just go back up to the table. But female, we already did. It was 22 out of 52. Is that total? Plus probability of going to college. Right here, 29 out of 52. And finally, probability of female in college. We just did that one here. Minus the 13 out of 52. Now, if you didn't have those individually, you would have to just do them separately and go get the numbers. You could also just do the numerator, right? Just get the counts, the numbers first, and then put them all over 52. Okay, in any case, we sum them. 51 minus 13, so we get 38 out of 52. What's that?